question concerns the use of PVC versus galvanized rigid steel, also known as GRS, conduit in gasoline dispensing stations, specifically regarding warranty requirements and the rationale behind using PVC-coated GRS. The user has experience using PVC conduit in these installations, citing exception number 2 of section 514.8 of the National Electrical Code. However, a new project requires the use of rigid steel conduit, GRS, throughout the system due to warranty demands from Fuelmaster and Bennett Pumps, the manufacturers of the fuel dispensing equipment. The initial justification for GRS was its ability to dissipate lightning-induced surges to ground, a function supposedly lacking in PVC. However, the current solution involves PVC-coated GRS, raising questions about its effectiveness compared to standard PVC. The primary concern revolves around understanding the technical reasoning behind this decision and whether PVC-coated GRS offers any advantage over PVC in terms of surge protection and grounding. Several factors may contribute to the preference for GRS or PVC-coated GRS in fuel dispensing systems. Firstly, grounding and bonding requirements are crucial in hazardous locations like fuel dispensing stations. The National Electrical Code, NEC, Article 514 addresses these requirements extensively. The purpose of grounding is to provide a low-impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protection devices like circuit breakers or fuses. This ensures that any fault in the electrical system is quickly cleared, minimizing the risk of electric shock or fire. Secondly, metallic conduits like GRS provide inherent grounding capabilities due to their continuous metallic construction. When properly installed with listed fittings, GRS conduit creates a robust grounding path that can effectively carry fault current. PVC conduit, being non-conductive, does not offer this inherent grounding capability. To use PVC conduit as an equipment grounding conductor, a separate equipment grounding conductor, EG, must be installed within the conduit. This EGC provides the necessary grounding path. Thirdly, the NEC permits the use of PVC conduits in certain hazardous locations, provided that specific conditions are met. These conditions typically involve the installation of a separate EGC and adherence to strict bonding requirements to ensure electrical continuity throughout the system. Section 514.8 exception number 2, which was mentioned, likely pertains to a specific allowance for PVC conduit under certain circumstances. Fourthly, the concern about lightning-induced surges is valid in areas prone to lightning strikes. Lightning strikes can induce voltage surges in electrical systems, potentially damaging sensitive electronic equipment. GRS conduit, due to its metallic construction, can provide a degree of shielding against these surges by diverting them to ground. PVC conduit, being non-conductive, does not offer this shielding effect. The effectiveness of GRS in mitigating lightning surges depends on several factors, including the grounding system, the length of the conduit run, and the severity of the lightning strike. Fifthly, the use of PVC-coated GRS introduces a layer of complexity. While the steel conduit provides the grounding and shielding benefits of GRS, the PVC coating provides corrosion protection. This is particularly useful in environments where the conduit is exposed to corrosive substances such as gasoline or other chemicals. However, the PVC coating also insulates the steel conduit from direct contact with the surrounding earth, potentially reducing its effectiveness in dissipating lightning surges. The question of whether PVC-coated GRS is better than PVC in terms of surge protection is debatable. On one hand, the steel core of the PVC-coated GRS provides a grounding path and some degree of shielding against surges. On the other hand, the PVC coating may impede the dissipation of these surges to ground. Ultimately, the effectiveness of PVC-coated GRS depends on the specific installation and the quality of the grounding system. To address the specific concerns, firstly, clarify the warranty requirements with Fuelmaster and Bennett Pumps. Obtain written documentation outlining the exact specifications for conduit type, grounding, and bonding. Understanding the precise requirements is essential for ensuring compliance and avoiding warranty issues. Secondly, consult with a qualified electrical engineer experienced in hazardous location installations. An engineer can assess the specific site conditions, evaluate the electrical system design, and recommend the most appropriate conduit and grounding system to meet safety and performance requirements. Thirdly, review the NEC requirements for grounding and bonding in gasoline dispensing stations, paying close attention to Article 514 and related sections. Ensure that the installation complies with all applicable codes and standards. Fourthly, investigate alternative surge protection devices. While GRS conduit can offer some degree of surge protection, it may not be sufficient in areas with frequent lightning strikes. Consider installing surge protective devices, SPDs, at the service entrance and at critical equipment locations to provide additional protection against voltage surges. Fifthly, document all decisions and justifications. Maintain a detailed record of the rationale behind the conduit selection, grounding system design, and surge protection measures. This documentation can be valuable for future reference and for demonstrating compliance with warranty requirements and regulatory standards. To provide a more comprehensive understanding, let's delve deeper into the relevant aspects of grounding, bonding, and surge protection in hazardous locations. Grounding refers to connecting electrical equipment and systems to the earth, providing a low impedance path for fault current. The primary purpose of grounding is to protect personnel from electric shock and to prevent fires caused by electrical faults. Bonding refers to connecting different metallic parts of an electrical system together, creating an electrically conductive path. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electric shock. In hazardous locations like gasoline dispensing stations, grounding and bonding are particularly critical due to the presence of flammable liquids and vapors. Any spark or electrical fault could potentially ignite these substances, leading to a fire or explosion. The NEC specifies stringent requirements for grounding and bonding in hazardous locations to minimize these risks. These requirements include the use of approved grounding electrodes, such as ground rods or underground metallic water pipes, and the installation of bonding jumpers to connect all metallic parts of the electrical system. Surge protection is the process of protecting electrical equipment from voltage surges, which are transient overvoltages that can damage or destroy sensitive electronic components. Voltage surges can be caused by lightning strikes, switching operations, or other electrical disturbances. Surge protective devices, SPDs, are designed to limit the magnitude of voltage surges by diverting excess current to ground. SPD are typically installed at the service entrance, at branch panels, and at critical equipment locations to provide comprehensive surge protection. The selection and installation of SPD should be based on the specific voltage and current characteristics of the electrical system, as well as the level of surge exposure. In the context of gasoline dispensing stations, surge protection is particularly important to protect the electronic equipment used to control and monitor fuel dispensing operations. This equipment can be vulnerable to voltage surges, which can cause malfunctions or failures. Now consider the specific types of conduit mentioned. GRS conduit offers several advantages in hazardous locations. Its metallic construction provides inherent grounding and bonding capabilities, creating a robust electrical path. GRS conduit is also mechanically strong, providing physical protection to the enclosed conductors. Furthermore, GRS conduit can offer a degree of shielding against electromagnetic interference, EMI, which can be important in sensitive electronic systems. PVC conduit is a non-metallic conduit that offers excellent corrosion resistance and is lightweight and easy to install. However, PVC conduit lacks the inherent grounding and bonding capabilities of GRS conduit. When using PVC conduit, a separate EGC must be installed within the conduit to provide the necessary grounding path. PVC-coated GRS conduit combines the advantages of both GRS and PVC conduit. The steel core provides grounding and bonding capabilities, while the PVC coating provides corrosion protection. However, as previously discussed, the PVC coating may also impede the dissipation of lightning surges to ground. The decision of whether to use GRS, PVC, or PVC-coated GRS conduit in a gasoline dispensing station should be based on a comprehensive assessment of the specific site conditions, electrical system design, and applicable codes and standards. It is important to consult with a qualified electrical engineer and to obtain written documentation from equipment manufacturers regarding warranty requirements. Ultimately, the goal is to ensure a safe, reliable, and code-compliant electrical system that protects personnel, property, and the environment. To further clarify the situation, consider the potential impact of using different conduit types and the overall grounding impedance of the electrical system. Grounding impedance is the total opposition to current flow in the grounding path. A low grounding impedance is essential for ensuring that fault currents can quickly and effectively return to the source, thereby facilitating the operation of overcurrent protection devices. GRS conduit, when properly installed with listed fittings, typically provides a low grounding impedance due to its continuous metallic construction. The grounding impedance of PVC conduit, on the other hand, depends on the size and length of the EGC installed within the conduit. A longer or smaller EGC will result in a higher grounding impedance. PVC-coated GRS conduit can offer a grounding impedance similar to that of GRS conduit, provided that the fittings are properly installed and that the PVC coating does not impede the electrical continuity of the steel core. In addition to grounding impedance, it is also important to consider the potential for stray currents in the electrical system. Stray currents are unwanted electrical currents that flow through unintended paths such as the earth or metallic structures. Stray currents can cause corrosion, interference with electronic equipment, and even pose a safety hazard. GRS conduit, due to its metallic construction, can potentially contribute to stray current problems if not properly insulated from the surrounding environment. PVC conduit, being non-conductive, does not contribute to stray currents. PVC-coated GRS conduit can help to minimize stray current problems by providing a layer of insulation between the steel core and the surrounding environment. In summary, the selection of conduit type for a gasoline dispensing station involves a complex interplay of factors, including grounding, bonding, surge protection, corrosion resistance, mechanical strength, and stray current considerations. There is no single best solution that applies to all situations. The optimal choice depends on the specific requirements of the installation and the applicable codes and standards. To make an informed decision, it is essential to consult with qualified professionals, to review relevant technical documentation, and to carefully consider all of the factors involved. And also, always prioritize safety and compliance with applicable codes and standards. Finally, let's address the specific concern about the warranty requirements imposed by Fuel Master and Bennett pumps. It is important to understand the rationale behind these requirements and to determine whether they are based on sound engineering principles or simply on arbitrary preferences. If the warranty requirements are based on technical considerations such as grounding impedance or surge protection, it may be possible to demonstrate that alternative conduit systems such as PVC with a properly sized EGC can meet or exceed the required performance. However, if the warranty requirements are based on non-technical factors such as brand preference or historical practices, it may be more difficult to obtain an exception. In any case, it is important to engage in open and constructive dialogue with Fuel Master and Bennett pumps to understand their concerns and to explore potential solutions. It may be helpful to provide them with technical data and analysis to support the use of alternative conduit systems. Ultimately, the goal is to reach a mutually acceptable solution that meets both the warranty requirements and the safety and performance requirements of the installation.